Hello and welcome to the Math Bender. I am Adnan Zaidi and we're going to be discussing third section of permutations and combination in which we'll discuss more about how selection happens. So when we talk about selection, the first thing that we need to have in mind that selection means no arrangement. So for example, if there are three people A, B, C, and out of those three people, there are two to be selected. So what matters to them is who got selected in any team. So there is, let's say, there's a football team which requires two players, and we'll get AB, BC, AC. Now what we are used to of doing is we write AB, BC. We've been doing that, taking out all the possible combinations. BA, CB, CA. Now there are total 6 combinations as we see if we look at the arrangement. But A and B are in the team, that is what matters. No matter whichever position or whichever name calls out to be first, that does not matter. What matters is that whether they are in the team or not. So what we do here is we write 3 factorial, and since we see that these are repeated 2 times, we divide it by 2 factorial, which gives you 3 times 2 factorial over 2 factorial, and it cancels out, hence 3, which I referred to this one previously. So when it's all about selection, it's only whether the person has gotten in the team in the selection committee, irrespective of the fact which position it is. I'll give you an example. For example, if out of 5 people, 3 people are to be selected, so those 5 people would want to be in the team irrespective whose name is called out first. But out of 5 people, 3 people are to get gold, silver, and bronze medal. Then the distinction that everybody would want to have gold. Now every position has its own significance then. So right now we are discussing selection only. So if we look at this, so it was a pretty simple case, and can try to sort it out and try to formulate it. This is as same as 3C2. C means choose, and we can use our calculator for that. We write 3, we press shift, we press C, and we press 2, and we get 3. I'll do it once again. So we press 3, we press shift, and we see that division sign has an NCR written. We press this and we press 2, which gives you all the possible selection. Let's look at an example here. 4 of the letters of the word paintbrush are selected at random. What matters here is that the letters were selected. So there is no restriction. We'll simply go with, there are 10 letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So out of 10, 4 are selected, which gives you 10C4 equals to 210. For part B, the letter T must be selected. So out of those, I need 4 letters, and in those 4 letters, T has to be selected. T is already there. So I do not have to count that in my pool of choosing events. So it is already selected. I'll place it here. Now, rest of the digits that I'm left with is 9, out of which the space that I'm left with is 3. So 9 choose 3, make it 9C3, and hence is equals to, there are 84 ways where I can select different combinations where T will be also a part. So let's see, a team of 5 members to be chosen from 5 men and 3 women. The number of teams that can be chosen if there are no restrictions. So when there is no restriction, there is no restriction on how many men or women, anyone can be a part of that committee. So we take total members, which are 8, and select 5 members. 8C5 will be all the possible ways in which one of the way would be 5 or all 5 men will be in the committee. For part B, there are restrictions. There has to be 3 men in the committee and 2 women. I cannot use this one because this has all the possible ways which are nullifying part B. For part B, what I'll do is I'll take my 5 men and select 3 from them, times with, there are 3 women and I'll select 2 from them. So whatever the answer that I get, so 5C, 3 times 3C2. This gives you, there are 30 ways with different men, 3 men and 2 women, that consist of no more than 1 woman. So the committee should not have no more than, means maximum women can be 1 in that. So what we'll do is we'll try to roughly make a map. 1, 2, 3, 4, 5. We'll keep 1 woman here and rest of them have to be men. So we can say that one of the condition can be 4 men and 1 woman. But there are other ways as well. When it says no more than 1 woman, it did not mention that is there any other possibility where no woman also be a part. So which means all can be men. What it put a restriction on the maximum amount of women. It did not mention in the question that the minimum amount of women can be none. So hence, this is going to be, out of 5 men, I'll select 4, times out of 3 women, I'll select 1, plus all of the 5 men, 5C5, are apart, and I'll add both of them. So 5C4 times 3C1 plus 5C5 is 1, makes it a total of 16 ways. Let's look at another question here. A test consists of 10 different questions. 4 of the questions are on trigonometry, 6 are on algebra. The students are asked to answer 8 questions. So if select 8 questions if there are no restrictions. So if there are no restrictions, any question can be solved. So out of those 10 questions, he solves 8. The number of selections that at least 4 algebra questions are solved. Now for at least means that minimum 4 algebra questions have to be solved, but it can be more than that. At least means 4 or more. So we'll try to make like 4 algebra questions, and there are 6. So in order they are to solve, so we can say that 4 trigonometry questions makes a total of 8 questions now. Or there is also a possibility 5 algebra questions and 3 trigonometry questions. Or we say 6 algebra questions and 2 trigonometry questions. There are no more algebra questions in the paper, and it fulfills the condition that at least 4 algebra questions, which means 4 or more. So this gives you that since there are total 6 algebra question, we'll write 6C4 times 4C4, which means in this scenario, he's choosing 4 algebra questions from 6, and all of them, since there are only 4 trigonometry questions, so he's solving all of them, plus 6C5 times 4C3 plus 6C6, which means solving all of the algebra questions and then choosing 2 questions from the lot. So once we solve all of them and add the values, we get the answer. So let's look at this one. 2 teams, each of 4 students, are to be selected from a class of 8 boys and 6 girls. Find the different ways the 2 teams may be selected if there are no restrictions. So there are 2 teams, each of 4 students. So when there are no restrictions, there are total number of people 14. We'll say 14C4 times with, now out of 14 people, 4 are selected, randomly different, and then they are left with 10 people, and out of those 10 people, still 4 to be filled within the next team is going to be 10C4. So if we find it out, it's going to be 210, 210. That's a lot of ways. One team is to contain boys only and other team is to contain girls only. So it's pretty straightforward, which means there are going to be 4 boys out of 8. I'll select 8C4 times with 6 girls, will 6C4. So one team having 4 boys out of those 8, different combination of boys out of those 8, and different combination of girls in the other team out of 6. A team of 6 tennis players to be chosen from 10 tennis players consisting of 7 men and 3 women. Find the number of different ways could be chosen if the team must include at least. Now please remember these terminologies. At least means minimum of 1 woman has to be there, could be more. So total players to be selected is 6. And there are 7 men and 3 women. There are total 10 players. So find the number. So we could do, what we could do is we write 5 men and 1 woman, for at least 1 woman to be a part, or it can be 4 men, 2 women, or it could be 3 men and 3 women. There are no women more than 3, so this is going to be 7C5 times with 3C1 plus, or means addition, 7C4 times 3C2 plus 7C3 times 3C3. So this gives you a total answer. You may write this as 7C5 times 3C1, total of 63. This is going to be 7C4 and 3C2, which gives you total of 105 ways, and 3C3 is 1 and 7C3 is going to be 35. So adding all of them, so 35 plus 105 plus 63, which gives you a total of 203 ways. Let's look at another question here. Ranjit has 25 friends, of whom 15 are boys. This is our Q line, and 10 are girls. He wishes to hold a birthday party, but he can only invite 7 of his friends. So, out of those 25 friends, if there are no restriction, whoever he calls will be 25C7. Only 2 of his friends are boys. So, out of those 7 friends, only 2 boys are invited. So, what we could do is there are 15 boys, and out of which a combination of 2 boys is selection, times with, since there are 7 friends and 2 boys are invited, so rest of them 5 people are girls. So there are total of 10 girls. We'll take 10, choose 5, and this is how 15C2 times 10C5 is 26460. There are 26460 ways where combination of 5 girls and 2 boys are going to be invited. The 25 friends include a boy and his sister who cannot be separated. Now, this is what we need to look at. So, let's say there are 7 people here. Now, there is a possibility that in one of the case, if a boy has to be there, his sister will accompany him. So, we can say brother and sister are a part of our combination. But if brother is not gonna come, sister won't either. So which means one of the combination can also be where both of them are not present. So 7 people won't involve both of them. So if 2 people are already brother and sister there, so there are total of 23 people left out of 25. So we say 23C, selecting 1, 2, 3, 4, 5. He can invite 5 people. Or brother and sister be included from the pool of 25 people, because if either they can be together or they cannot be together. Hence, this fulfills our condition of they cannot be separated. So, 23C7. In this case, there are 5 people involved where 2 of the other people are out of 7 are brother and a sister. Then they cannot be separated. Then there's another scenario where brother and sister are not part of those 7 pool of friends which are invited. Let's look at another one. Tickets for a concert are given out randomly, a class of 20 students. No students given more than 1 ticket, and there are 15 tickets in all. So there are 15 tickets, 20 students out of those 20, see 15. There are 12 boys and 8 girls in the class. So out of them, 10 boys has to get a ticket. So 12C10 times with 8C5. That's how you distribute 15 tickets. All the boys get the ticket, which means all 12 and 12 got the ticket. So you can write this as 12C12. All of them got the ticket times. There are 8 girls remaining, and there are 3 tickets after spending all the tickets to giving all the tickets to boys. So there are remaining 3 tickets. So it's going to be 8C3. I hope I've made myself clear. Do write in comments if you feel like if you have any question that you want to ask. I'll see you in my next session. Take care. Bye.